Hello guys, welcome back to class. In this session, we'll start with other operators. In the previous sessions, we completed arithmetic, string concatenation, assignment. In assignment, simple assignment, compound assignment. Then we have seen increment, decrement operators. So in this, we'll start with relational operators. So what are the relational operators? There are 6 relational operators: less than or equals, greater than or equals, equals, not equals. The 6 relational operators we can divide into 2 groups. One is comparison operators. One group is comparison operators, and second group is equality operators. Comparison checks either less than, greater than, or not. Equality checks equal or not equal. So equality, 2 operators. Double equals checks equal or not. Not equal. Not equal or not. And comparison, 4 operators. Greater than or equals, less than or equals. Less than or equals is 1 operator. 2 combination is 1 operator. And if you see the examples, basic examples, and these are most widely used operators. Whenever you do conditional statements, if you are writing if statement, for loops, without a for loops, if you are not going to write any code, any smaller project to develop, any bigger project to develop, without conditional statements or looping, I think you are not going to write any code every day. So whenever you want to write a looping and control statements, you must have a conditions always. Conditions you are framing with this relational, and the next we are going to talk logical operators. The relational logical will be used to frame the conditions. So for example, I am taking as 10 greater than 20, 10 less than 20. So what it gives, what can be the result of this? What can be the result, guys? 10 greater than 20. It gives either true or false. So this gives only false. 10 less than 20. It gives us true. And this side, if you take 10 not equals to 20. 10 equals to 20. 10 equals to 20, false. 10 not equals to 20 is true. So what we understand? Resultant type is a Boolean. Resultant type is Boolean. When you are learning about operators, what you have to learn, guys? What are the points you have to learn? Number 1, purpose. Purpose is to compare. Relational operators to compare, comparison or equality. Simple purpose. Okay, I am not writing the purpose. Already this is to compare. Comparison operators for comparing, equality operators for checking the equality. That's the main purpose. Second is whether these are unary operators or binary operators or ternary operators. How many operands required? How many operands required for this? How many operands, guys? It seems 2 operands mandatory, right? So these are binary operators. Binary operators. These 2 also binary operators only. Okay. Next, result type. What is the result type here? And what is the result type here? What's the result type, guys? Is a Boolean. In both the cases, all relational result type is Boolean. Binary, Boolean. Binary, Boolean. And next point to study, operand types allowed. What operand types allowed? Two operands are allowed. Two operands are allowed, but what types are allowed? What types are allowed? You see above I written as a 10 less than 20. It means numbers. Can I use the numbers? You can use the 6 number types or numeric types and the 1 char type allowed. And in the case of relational, you cannot use the Boolean and string. Remember it. You cannot use the Boolean and string. For example, numeric, anything okay. Suppose 10.5 greater than 9.2. Double or float, whatever. This is fine. But you can't say true greater than false. True greater than something. This operand type itself, Boolean itself not allowed. And when you have a strings, for example, string less than string, this comparison also not allowed. Only allowed types here are numeric and char. And in the case of equality operators, the operand types, here you can use extra. 6 numerics as it is you can use, and the 1 char can be used like previous. In the equality, you can use a Boolean type also, guys. And even string type you can use. Not exactly string type. I can say any reference type is allowed. Any reference type allowed. Any reference type allowed. Equal, double equals, equals, not equals. You can use any reference types. String is one of the reference type. And coming to the primitives, all 8 primitives allowed. All 8 primitives allowed, 6 numbers, 1 char, 1 boolean. 8 allowed, plus any reference type. String is the one. Anything can be used. For example, the other all types allowed here. Examples, if you see 10.5 equals to 10.2. Numerics, char, boolean. You can also say true equals to false. You are telling true equals to false. What is the result of this? What is the result of this? I am telling true equals to false. What is the result of this? Is it false? 10.5 equals to 10.2. False. And the strings you can use. For example, you write the string JLC in double quotation equals to suppose again JLC in double quotation. This result we can't decide currently. When use the reference types, it will compare the addresses internally. That we'll discuss the more about that later. Suppose I am writing str1 equals to str2. This actually compares the address of str1 and address of str2, not the content of str1 or the content of str2. And as I told, any reference type allowed. Suppose you have a customer object. One customer, cust1 is a reference variable of customer class. Cust1 equals to cust2. Or you have a account object. Account ACC1 equals to ACC2. Like any reference types, you can use the equals, you can use even greater than, less than, not equals also we can use. But for reference, other reference types, we can't use the, for other reference types, we can't use the comparison operators less than or equals, greater than or equal. So is that clear about relational? All relational operators are forming the expression called relational expression. So whatever you call, this is a relational expressions. Expressions also called as a condition. Relational expression is called as condition. You're writing condition. So clear about relational operators, guys? Points. Quickly summarizing, relational operators are two types: comparison operators, equality operators. Comparison operators are 4, greater than or equals, less than or equals. And equality operators are 2, double equals, not equals. And these are comparison operators are binary, equality also binary. Result of comparison is Boolean, result of equality also Boolean. Operand types allowed for comparison, only numeric and char. Whereas operands allowed for equality operators, double equals and not equals. You can use numeric, char, Boolean, string, any reference types are allowed. So is that clear? Can you go to the labs now? You have to say something, yes or no, then only I'll understand. If you sit silently, I won't understand. Very good. Start the labs on this. Okay. So previously we done 107, right? Now we have to do the 108 lab. Lab number 108.java. So I'm taking one simple byte. First I'll do a comparison with. For comparison also, they must be compatible. For comparison, they must be compatible. You want to compare, the types must be compatible. These are binary operators. Operand 1, operand 2 must be same or compatible. I missed that point. Remember this point. They must be, types must be same or compatible. Types must be same or compatible. Now in this case, tell me, types are same or not? To compare two operands, to compare two operands, to compare two operands, their types must be same or compatible. Types must be same or compatible. Okay, that is the important point we need to take. So currently tell me, so I am comparing capital A in single quote. What is the type of this? What is the type of this, guys? Is a char. And then 65 is integer. So int and char are not same, but int and char are compatible. Int and char are compatible to compare. So okay. Next I am using byte b equals to 65, for example. I use byte otherwise. Yeah. Byte b equals to this. So byte, I will be trying to compare with all types. So byte, I am comparing with the character. Byte with character, compatible or not. And next, integer with character, 65 integer with byte. Okay. Then we'll take 65L. 65L. Long and byte I am comparing. Long and char I am comparing. Long and char I am comparing. And 65.0, it means the double I am comparing. Char with the double. 65.0 F means the float. Float with a char I am comparing. So in this, I think same comparison I am not doing at all anywhere. Same means we know, right? Integer can be compared. Float can be compared. Double can be compared. Same types always. The goal of this lab is to test the compatibility. When you are comparing, compatibility. I think among the number types, always you can, number types are always compatible to compare. Am I right? Number types are always among a number and char, 6 plus 1, 7 types, 6 number and 1 char. These 7 types are compatible for comparison. Compatible for comparison. Compatible for comparison. 108 Java C Lab 108.java. All are okay. All are same actually, right? True only. Everything true only. Because if you see the first one, A, character A is equivalent to 65 only. We are comparing this. Same character with byte, int with byte, like all versions. This is comparison. Remember, in the case of assignment, the story is different. In the case of comparison, the story is different. See, if it is assignment case, whatever we discussed, we spent a lot of time on assignment in the previous session. Now, we are talking about a comparison, relational operators. In the assignment case, number and char types are compatible each other. In this also same thing. Number and char types are compatible with each other. So because of compatible with each other, you can compare with anyone among number types. You can compare with anyone among number types. But in the assignment, what is the key point we studied? These are number types also, number types compatible anywhere. But in the case of assignment, lower to higher, automatic conversion, right? Implicit casting is happening so that we are not getting any error. But when you do higher to lower, then explicit casting is required. That's a story we studied. Because of assignment, whether you're assigning higher to lower or lower to higher. Higher to lower means explicit casting is required, you have to do the casting. Lower to higher means automatically conversion is happening because it is safe conversion, right? But in the comparison, is different story. These are all fully compatible. You can do direct comparison anytime. You can compare int with the double with the float with any among these 7 types, anything you can compare without any restrictions, right? So compare these all 6 number types and the Boolean 6 number types and char, you can compare among each other without any restrictions. So here we try to do all the combinations, everything fine, doing it. Next. 109. 109. So I'm taking double D1 equals to this point. I think somewhere we discussed 13 by 3.0 F. Somewhere we discussed this D2 equals to 13 by 3.0 D. If you're not writing also double, if you write also D, double. I'm not writing. So I will be comparing D1 and D2. D1 value equals to D2. So it tells D1 equals means true, otherwise false. So what is the result of this? Whether it will give us a true or false. Pavani, Naveen, false. Vishnupriya also false. Why false? Why false, guys? Any reason? Double precision is more than the float. Yes. Very good. If you want to print the values of D and C, values of D1, D2, you print so that you can understand the value difference also. I'm printing D1 and D2 also. See, the precision values are different. That's what making us, there's a clear difference in that. Right. Next, we have other operators, comparison operators. 110, less than or equals, greater than equals. All are going to give us a Boolean flags, true or false, right? When you use any of the operators, they'll give just true or false only. So all operators, I'll try to use in one lab. Just to say the result is, suppose 10 less than 20. 10 less than or equals to 20. 10 greater than 20. 10 greater than or equals to 20. 10 equals to 20. 10 not equals to 20. Okay. So all types. Result of all of these operators is a Boolean. So it has to give either true or false. Whatever the value, whether you are using 10, 20 comparison, secondary for us. Value can be anything. We want to check whether all written type is Boolean or not. 110.0. Okay. Yeah. True, true, false, 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 and true. Okay. Now, if I want to compare the Booleans, which operators can be used? For Booleans, which operators can be used? For Booleans, which operators can be used, guys? For Booleans, equality operators can be used. So can I say this is 111? True equals to true. The equals to operator can I use here? True equals to false, like this. Even not equals also. True not equals to false, and true not equals to true. Only these four combinations with the Boolean, right? Equal and not equal operators can be used with Boolean also. But comparison, less than, greater than, less than or equals, greater than or equals, we can't use with Boolean. Right. So this simply compiles true equals true is a true, true equals false, true not equals to false is a true, True not equals to true is false. I think true, false, true, false. Very good. Simple, very simple. True, false, true, false. Done. 112.java. True greater than or equals to true. True equals to 0. So what do you say on this? I think okay. I am thinking okay. What do you say? You say. Greater than or equals is a comparison operator. Can I use for comparison operators, can I use a Boolean operand? Boolean operand is not allowed, right? So there are two statements. This is a one statement and this is second statement. I am doing two different mistakes here. In the statement one, the mistake is for comparison operators less than or equals, greater than or equals. For these four comparison operators, Boolean operands not allowed. Correct? And second one, what about second one? True equals to 0. When you are comparing true equals to 0, see this very clearly. True equals to 0. So this is equality operator. For equality operator, what operands allowed? For equality operator, what operands allowed, guys? 6 numeric types allowed. 6 numeric types allowed. 1 char type allowed. Boolean also allowed, right? For equality, Boolean also allowed or not? Boolean also allowed. Numeric allowed, Boolean allowed. Numeric allowed, Boolean allowed. Numeric allowed, Boolean allowed. So here I am using numeric. Okay. Here I am using Boolean. I think this is okay, right? I think this is okay. What do you say, guys? Second statement, is that okay? Pavitra is telling not okay. Monica is telling use same type. It should be compatible. Very good. Very good. You got the point. These are allowed okay. Boolean allowed okay. Integer allowed okay. That is a one rule. But second rule is when you are comparing, the two operands must be same or compatible, right? Two operands must be same or compatible. Two operands must be same or compatible. Now you are comparing true Boolean. So not same. Not same. Whether Boolean and integer compatible? Boolean integer, guys. These are not same and then not compatible. Not same and not compatible. Am I right? Not same, not compatible means not comparable. If not compatible, not comparable. If not comparable, not convertible. These three important terms with the C you remember. So this error is clear, right? Statement to error is clear. Those are types are not same, but not compatible also. If not same, not compatible, we can't do comparison, right? Compatible, comparable, convertible. C. Compatible. If compatible, then only comparable. If comparable, then only convertible. Compatible, comparable, convertible. So first you see these two, Boolean and integer, whether these are comparable or not. Boolean integer, comparable or not? Boolean integer comparable or not? No, not comparable. How you are saying not comparable? How you are saying not comparable? Because not compatible. Because not compatible. So when not compatible, not comparable, and also not convertible. Not convertible means assignment, you see. Int x equals to true. Can I do this? You can't do. And even forcefully, if I convert to Boolean like this, can I do? Int x equals to int of true. Can I convert like this? Can I convert like this? You can't do. So convertible, no. Convertible, no. Comparable here, no. Because not compatible. Is that clear? If not compatible, those are not comparable and not convertible also. If not compatible, not comparable and not convertible. These three are the three beautiful words. Comparable, compatible, convertible. Is that clear? So I think this lab 112, we are getting the two errors, right? Two errors. Can you tell me the error names, exactly error messages? That is, if you are a super expert in Java, you should tell the error name also. Means you have to remember thousands of error messages in your mind. So we done at least 100 programs. This is a 112, right? 112 means 100 plus error messages we got already. Possible lossy conversion, I think no, Pavitra. There's no point of, we're not assigning anything, right? Conversion, you are not, are you doing any conversion here? Lossy conversion, you are getting means you are doing conversion, right? Are you converting types here? No. When you are not converting, then it won't come. Incompatible, one you say, okay. Second one, 112, guys. Incomparable, I just told you guys. Incompatible, no. Incompatible only. These are not compatible, means incompatible only. But very clearly, because you are doing comparison here, right? You are comparing true with the int. Second statement, I am talking about a second statement. You are comparing Boolean with integer. Comparing Boolean with integer. So they are telling clearly, boss, incomparable types. Boolean and int are incomparable. You can't compare this also. And you see this is what I expected from you, but you didn't say that. For every operator, there are a standard operand types, correct? For our greater than or equals is equality operator. For this operator, what operands allowed? For this operator, what operands allowed, guys? 6 number types allowed, 1 char type allowed. Only these are allowed. When these are allowed, if you are using something else which is not allowed, what it has to tell? Whenever you are using an operand not allowed type, it always gives the bad operand types for the binary operator greater than or equals. For greater than or equals, Boolean is a not allowed, right? So when you use a not allowed operand type, it gives always a bad operand type. So whenever you see bad operand type error message, it means you are using a wrong type for the given operator. For any operator, we are seeing we have a total of 30 plus operators. For every operator, it is very clearly fixed that this operator purpose is this, result of the operator is this. For this many number of operands allowed. The operand types are these only allowed. Operand types are clearly fixed for every operator. You have to use those only. If you are using other than those, it gives an error message called bad operand types for a given operator, so and so. Right? So is that clear, guys, about this lab errors? Very good. Next. So we're done with the 112. Next we have 113. 113.Java. Some int a equals to 10. Okay. See how I'm going. This again important. You have to cross check. RESULT. RESULT. Result is I'm printing a result plus a equals to a. I think you understand what is my intention to do here. What is my intention to do is I got a work that I have to compare a with a. Some result will come. A equals to a. What is a equals to a, guys? A currently 10 only. 10 equals to 10, which is true. So I want to display result is true. That is my intention. So if I compile and run this, what do you say? What is the output? Very simple program. Maybe any trick is there in this, or straight away answer is there? Any trick? Maybe I don't know. Okay, I will ask the compiler first. This is, I just told you, similar to that, but incomparable types, string and integer are incomparable. But I did not compare a string and integer. Who compared? I didn't compare string and integer. What is going on in this, guys? What is going on in this? I did not compare. My intention is I want to compare a with a. Int comparison allowed. Then result true. I want to concatenate with the string. But it is giving error. What happened? It means the operator precedence has confused us. So what happened internally? What happened is maybe we are using two operators, not maybe. Clearly we are using two operators here, plus and equality, plus and double equals operator we used. And these two operators precedence same. Same means first what it is doing, first it is comparing, guys. First it is doing the string concatenation, I think. First is the string plus integer equals to integer. This is what you have written, right? String plus integer. So what is happening? First plus happening, concatenation. It is doing string plus int. What is string plus int? What is string plus int, guys? String only, concatenation. String equals to integer. So finally, this is happening as second operator. String equals to integer. These two are opposite families, right? We have seen the string, Boolean, numbers, the string family, Boolean family, numbers family. We drawn the diagram, right? These are not compatible. Compatible means not compatible means not comparable, right? Compatibility first, then comparability. No comparable. These are incomparable. You understand? So how can I correct this then? How can I correct this? Tell me the answer for this, right answer for this. When you have a multiple operators, yeah, this I am commenting, guys. When multiple operators are there, important term to check is priority. So first I want to do comparison, then keep that in a bracket. Yes, I kept this in a bracket. Now first comparison happens. In comparison, number will be compared. It will give whatever true or false. Then the result true can be concatenated with a string. I will get something as result is either true or false, whatever it gives. For every operator, remember, for every operator, I am giving priority related one lab to alert you. Result is whatever we have, something. Okay, that is about relational operators. 6 relational operators, we have done it. Now, next is the logical operators. Next we have logical operators. So what are logical operators? There are 3 logical operators. One is the AND, OR, and NOT. This you have to call it as, always remember guys, you call this as logical AND. Logical AND. This is logical OR. And this is logical NOT. Why I am asking you to call specially logical AND, logical OR, logical NOT? Because we have a bitwise operators also. We have bitwise AND also there. This is the AND operator. This is also the AND. This is AND, this is AND. But double means logical AND. Single means bitwise AND operator. Okay, that's what this is. We are talking about logical operators. Bitwise we'll talk later. Okay, these 3. In this is a binary, guys. This is a binary operator, and this is also binary. AND and OR are binary operators. NOT is a unary operator. NOT is a unary operator. It needs only one operand. It needs only one operand. The main goal of the logical operators is, to combine 2 or more relational expressions. Relational expressions. What are the relational expressions? What is the meaning of relational expression, guys? Tell me an example of relational expression, you know. Tell me an example of relational expression. Very good. 10 greater than 20 is a relational expression. Tell me an example of arithmetic expression. Maybe you hear the term arithmetic expression. Arithmetic expression, tell me. 10 plus 20. It means if you are forming an expression with arithmetic operators, it is called as arithmetic expression. If you are forming an expression with relational operators, it is called as relational expression. Simple, right? Similarly, what is a logical expression? Logical expression is an expression which is combined with logical operators. Okay. First, take the relational expressions. Suppose I am taking A greater than B is one relational. A greater than C, maybe D greater than B, something like this. So can I say these are the relational expressions? These are relational expressions. To combine this, maybe this is one condition. Relational expression also called as condition. This is another condition. This is another condition. So for this, you can use this logical AND. Means this condition and the second condition, both must be true. And maybe I can use here as OR. This can be OR and anything like this. So what is this? Is this a logical expression, guys? Is this a logical expression? Which is combination of combination of three relational expressions. Am I right? Is a combination of three relational expressions. A greater than B is one relational expression. A greater than C, another relational expression. D greater than B, another relational expression. I have a three relational expressions combined with the logical operators to form a logical expression. And tell me, what is the result of the logical expression? What is the result of the logical expression? By seeing this, I think you can answer it. Result, guys. Result Boolean, very good. Result is the Boolean always. Result is a Boolean. And operand types allowed? Operand types allowed, please. What operand types allowed? Means if you take AND operator, guys, this is AND operator. For this, what is allowed? Which is a binary. AND operator is a binary operator, right? So what is allowed? See, I want answers from others, all of you. No, my question is not operators, Pavani. Question is, what operand types allowed? Only Nikita has answered it as a Boolean. See, these types must be Boolean only, guys. Operand types must be Boolean. Must be Boolean. No numerics, no char, nothing. How it is, I'll tell you. See here. You have 10 greater than 20 and some 15 less than 25, something like this. So here, this is a relational expression. Second is a relational expression, right? You are using logical operator. You are using a logical operator and is a logical operator. You are using this to combine two relational expressions. What is the result of relational expression? What is the result of relational expression, guys? What is the result of relational expression? Boolean. What is the result of this relational expression? Boolean. So what is this operand type now? Boolean. What is the operand type now? Boolean. So operand types only Boolean allowed, nothing else. Logical operators, first is the logical AND is the binary. Logical OR is the binary. It means they allow two operands. These two operands must be of Boolean type only. Can I use like this? 10 and 20. Is this okay? 10 and 10, logical and 20, not allowed. Logical operators, operand types must be Boolean. Clear? Make it fixed. For logical operators, operands types only one allowed Boolean, no numbers, no char, only Booleans. Okay? Very good. I think you have seen this truth table somewhere. I don't know. Suppose A, B, A and B, A or B and not B values. A, B, A and B, A or B. Not A is the unary operator, guys. Not A is the unary operator. True, 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 false, false, true, and false, false. Have seen something? A and B. A and B are the two operands. Must be Boolean. So true and true. Result is true and true, guys. Have you seen this anytime? Yeah, true and true, true. In the case of and, when both are true, true. If anyone is false, all remaining false. Only true and true, true. Remaining are false. And AR. R means I am telling either this is true, okay, that is true, okay. This is true, okay, that is true, okay. Anyone is true, true. Anyone means first one is true, okay. Both are true means happy. Second one, true or false. Any one is true, okay. False or true. Second is true, okay. Both are false, false in this case. Not means the negation. Negation means A. Take the A value. A true. A true means not A false. A true, not A false. A false, not A true. Last A false, not A. So in the case of and, 1 point, when both are true, then it is true, otherwise false. In the case of or, when both are false, it is false, otherwise true. In the case of not, true means false, false means true. So is that clear, guys? So for this, logical operators, we have 3 logical operators: logical and, logical or, logical not. Logical not is a unary operator. It takes one operand only. Not A means true means false. Reverse it. Reverse. True means false. False means true. Logical and logical are the binary operator. And these all operators result type. First they take the operands. The operands they take are Boolean only. Result is a Boolean only. According to this truth table, it will give finally true value or false value. Clear, guys? You will use this relational operators, whatever we seen just now, 6 relational operators, and these 3 we will use heavily, heavily, heavily. Should have a super clarity on this, guys. For example, you take one real world example. Case 1 I am taking, one use case 1. Say, in my, you are developing a bank project, guys. When you're developing a bank project, customer must have email ID and a phone number. They must have a email ID and phone number. How to check that condition? Customer must provide the email ID. Customer must provide the phone number. Suppose to store the email ID, I am declaring email variable. So what I have to check now? Email not equals to null and phone not equals to 0. Why I am taking not equals to null and phone not equals to 0? Because when you declare email ID, for email, what data type you declare? Email must be string, right? Phone number means we need a 10-digit number, guys. Integer not okay. You have to go for a long for the phone number. Phone must be long. So assume customer did not provide the email ID. If email ID is not there, what will be there in the email variable? Default is null only. If email is provided, email will be there. Otherwise, null will be there. Phone is a long type. If phone number is provided by the customer, phone number will be there in the phone variable. Otherwise, phone will contain a 0. So what are these two? Tell me. These two, what is the expression? What is this, guys? Individually I have written. I didn't use any logical as of now. I didn't use any logical operator here. I have 2 expressions. Relational, right? Relational. Call it as the relational. This is my relational expression. This is separately my relational expression. Now you have to combine. Why you combine? Your bank use case may be something like this. Suppose anyone okay, guys. Anyone okay. Both not mandatory. Either you provide email ID or phone number. Anyone okay. How to check? At least one should be provided. Either you provide email ID or phone number. Anyone okay. So which operator I had to use? Consider this is my condition 1. This is my condition 2. So what I have to say? Condition 1 or condition 2. If any one is true, fine. R is enough. Or my manager told, no, customer must provide both. Both must be provided. Then what I have to check condition, guys? C1 must be true and C2 must be true. Like this, you will have many real world use cases to use these operators. So make sure you have super clarity on these operators. Okay, guys. So is that clear about logical operators? Can you go to the labs now? Can you go to the labs now for the logical operators? And we have to see other points also about logical operators. Okay. Now 113 we are done. We have to go for 114, guys. These three one by one we'll study. 114, three operators, right? So first we'll say about not operator. Not is very easy. True means false. False means true. Okay. So I am just printing a true. I am just printing a false. Okay. Nothing. I am printing true, printing false. Okay. Output is true and false, right? Okay. Nothing is there in that. I want to reverse this. If I say not true, what happens? Not true means it gives a false. Not false means it gives a true. We will use this later in many examples, guys. Many examples will use this. But you just learn the fundamentals only now. See, reversed. Not operator, reverse the Boolean flag. Clear? Next. Not operator is a binary operator or unary operator? Not is a binary or unary, guys? Unary operator. Very good. And what operand types allowed? What operand types allowed, guys? What operand types allowed? Boolean only. Are you sure? Are you sure? Boolean only. Okay. You tell me what happens now. 1 on 5. Int a equals to 10. I am saying not a. What happens? Bhargav, Malik, Naveen, Pavitra, Pankaj. It is not a Boolean. I just told you answer also. Not a. Not, listen carefully my sentences. Not is a unary operator, one operand allowed. What types of operands allowed for not? What types of operands allowed for not? Boolean only, right? Then what you are using? Integer you are using. Can I use integer? No. Integer is allowed? No. Then you are using something which is not allowed. You are using something which is not allowed. You are using some operand type which is not allowed. You are using some operand type which is not allowed. Bad operand. Bhargav Malik. This operand type is not allowed, right? Precisely finding the error is very important. Precisely finding the error is very important. That comes with a more practice, more practice. Same lab, you analyze multiple times. Easy only, guys. I just done a small labs. Spending a lot of time on the fundamentals only. These fundas are, if you are strong in fundas, advanced any new skill learning is very easy. Okay? But this in the operand types, what is allowed? Boolean allowed. Other than Boolean, anything you should not use. If you use anything other than that, it will give only bad operand of type something. Okay? Error. Very good. Compile time error. 116. You have to record all these errors. I don't know whether you're recording all these errors or not. 116. Check carefully. Next, I am using int a equals to 10, not a equals to 10. My intention is, see, a equals to 10. What is a? A is integer. Okay. Whose value 10? 10 equals to 10. Can I do this operation? 10 equals to 10. Can I do this operation, guys? Yes. Result is true. For this true, I want to reverse. So not true. I want to get as a false output. That is intentional. I write on this expression. Do you have any opinion on this expression? What do you say about this? Anything to say on this? Maybe error you're expecting? 116. Priority is important, guys. Again, the bad operand. What it is? Two operators are there here, guys. Two operators. Which operator is running first? It is not doing comparison first. It is not doing comparison. It is doing not operator first. Not is taking priority. So first it is running not A only. It is running not A. Not A means for not A integer type is not allowed. Bad operand type. Understand? Compile time. Error. So we are done with what is this? Not operator, how to use. And for the logical and logical OR, these are the binary operators. We need two operands, and operand types must be the Boolean. And we see in the truth table also. In the case of AND, when both are AND, the result is AND. Otherwise, false. Result is true. In the case of OR, both are false, result is false. Otherwise, true. Or you say anyone is true, true, otherwise false. So based on that, I think we can do the labs. Okay. 117, I'm going, guys. About the AND operator, we'll see. First, we'll understand a truth table of AND. Just practice a truth table of AND. How to truth table? True and true. What it gives? True only. And true false. F-A-L-S-E. F-A-L-S-E. True false. Already we have seen the truth table. True, 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 false, false, true, and false, false. Okay. Only true and true, true. All remaining cases, false. Simple. Just revising truth table from this lab. Nothing, other points not there in this. Okay. Okay. Now is the important practice of this. 118.java. some into a equals to 12. Not into Boolean I'll take, because result always will come as a Boolean. Boolean b equals to a greater than 10 and a plus plus less than 5. You should be, if you are very thorough with my previous classes, you can answer it properly. How strong you are in the previous sessions, you will come to know here. Tell me. All in one. Thirteen false. Hari's answer is 13 false. Others do. A initial I have taken as a 12. The expression you take a greater than 10. This is a relational, and a plus plus less than 5 is this is relational. This gives a true for us or false. This gives true or false. Then we will decide a final result will store in B. Okay. So now first expression a is a 12, guys. 12 greater than 10. And this is a plus plus. And here, this expression only you take. Here is a twist. In this expression, how many operators are there? In this expression, how many operators are there? 2 operators. Plus plus is there, less than is there. So which one has to happen first? Plus plus less than. If the order you change, output will change. Order you change, output will change. You're considering as a plus plus happening. Okay, do that. First a plus plus I am doing, means a value increasing by 1. So this 12 will be changed with 13, a increased. So what is the result of this? 13 less than 5. What about this result? 20 greater than 10. Is it true? And 13 less than 5 is a false. And true and false means the final value is a false. So now after finishing the expression, print A is 13, print B is false. Okay? Okay, 13 false. Check here. What is this? 119, huh? 118. Thirteen false. So correct. Less than plus plus operator precedence. Table you have to by heart. I think table is given in the booklet. Is that, have you seen that operator precedence table given in the booklet? You by heart that. In the table I given clearly order, which is the first, which is the last. So this is clear, guys. We predicted the output clearly. Similar lab I am making one more. Understand it very clearly. 119.java. Everything same as it is. Small change. Instead of 10, I am giving this as a 15. That's it. Instead of 10, I am giving this as a 50. This is only I done a change, guys. Everything same. You tell me how to tell me this output. Clearly think and tell me what happens in this. Everything same. Only 10 I replaced with this. So I want A value, B value, Govardhan, not just true. Tell me A value, what B value. What will be the A value? What will be the B value? Clearly I want, guys. Bhargav 12 false, Hari 12 false, Pankaj 13 false, Muhammad 13 false, Poonam 12 false. But why are you telling a 12 false? My question to you, because A plus plus is there, right? A plus plus is there anyway, right? That I didn't change, I didn't remove. A plus plus is there. A plus plus is there means A value has to be increased. The second expression I did not change. It seems 13, A plus plus, A will be increased to 12. Then 13 less than 5 is a false only. Second becomes a false. First, A is a 15 I given. So 12 greater than 15 is a false. False and false is a false. Is it a 13 false? Or whoever told as a 12, if you have any reason behind that? Oh, very good. Bhargav, Harishankar, you are on the. So these operators are called as short circuit operators. Short circuit operators. This is a AND operator is a and OR also. And OR are short circuit operators. What is the meaning of short circuit? See here, this expression is A greater than 15, guys. A is a 12. 12 greater than 15. 12 greater than 15 is a true or false? 12 greater than 15 is true or false? False only. 12 greater than 15 is how true? Like false, right? False. In the case of AND, in the case of AND operator, when a first is false, any need to see the second one? Any need to evaluate second expression? Okay, no problem. Any need to check the second expression because AND case, logical AND case, one is false, the entire result will be the false. No need to see second side what is there also. No need to check second side. So because of short circuit, when first is false, no need to check about second. It's straight away I can announce the result is false only, right? Understand? See, in the case of AND operator, guys, we know that false, true, false only. False, false only. Right? False only. False, true, false only. False only. If I know the first one is a false, second may be true also, result is false only. Second may be false also, result is false only. Then why to see the second? Why to evaluate? It is optimized operator. This is one kind of optimization technique. They are not spending a time and energy, memory on performing second expression evaluation. When a first expression, in the case of AND operator, when the first expression gives the false, second expression, second operand related expression will not be evaluated. It won't do C there. It will straight away decide the result as a false. It will tell B value as false without evaluating second part. Based on this is a false. It assigns a false into this. Comes to next step means time saving. Doing the faster, right? Optimized. Short circuit operator is an optimized operator. That's what 12 is. Increment is not happened actually. It is 12 and false. Do you understand, guys? This lab understand? And here I'm exploring about a short circuit operator, which is an optimized technique. It is not evaluating when first expression is false. In the previous example, suppose first expression is true, guys. Then I have an AND operator. I have a expression 1 and expression 2. AND operator is there. First one is true. When a first one is true, can you decide the final result without seeing the second one? No. You have to go and check this also. If second is coming true, give the result as true. Second is coming false, give the result as false. So when first is true, it has to evaluate this. But first is false, you no need to go for a second option. You straight away say that this whole expression is false. That is the short circuit, which is an optimized technique, saving a time for us, not evaluating. That is applied here, right? That's what output is 12 and false. It is 12 and false. Very good. 119 is done. Compile and run and show the output. Twelve and false. Very good. Now about the OR operator. OR also short circuit only. I designed labs for that also. First one, 120. We'll see the OR truth table revision. 120 OR truth table revision, guys. OR truth table revision. This is all take out. OR truth table means true or no. OR means this. True or true. Result is true or true, true or false, false, true, false, false. Any one is true, the result is true. Am I right? Any one is true, the result is true. Any one is true, the result is true. Means first three true, the remaining is a false. Very good. Simple. Now, I'll take the previous lab. What is that? 120, not 119, 118, right? 118, I am taking as 121. I'll just change, instead of AND operator, I will use OR operator. A equals to 12, B equals to A greater than 10, or A plus plus less than 5. Print A value, B value, lab number 121. You think and tell me correctly how to answer it. Everybody has to correctly answer, because whatever the stuff required to analyze this lab, everything you have in your mind. Only properly apply and tell me the correct output. Think, guys, carefully think and tell me. So there are odd outs here also. Ramesh is the one, Poonam is the one, and who are 13 gang? Sabih also in the 13 gang only. Samir also in 13 gang. At least I'll show you the answer. You can understand it. Means you are not applying all the guys are not applying all the points. What is the operator used in this program? At least name it. What is the operator used in this program? OR operator. Is that a short circuit operator? Is that a short circuit operator? Yes. If yes, then answer we got as a 12 and true. 12 true. Why this is the output? I think most of you 90% answered this. Only 10% my good students answered 13. Means they missed the point. Again, Monica is telling 13 true. How, Monica? I executed this 121. You didn't see that? Answer is 12 true only. You are expecting that, but it's 12 only. But why? Oh, I think you need a lot of practice, guys. A plus plus less than, this is an expression you are written, guys. Okay. Now, A is the 12. 12 greater than 10, or remaining is there. 12 greater than 10. Is that true or false? True. In the case of R is a short circuit. It will decide the output. When my R case, when my first operand is true, any need to see the second one? In the R case, any one is true, the result is true, right? Any one is true, the result is true. When my first result is true, second immutable guys for me, second can be true or a false, whatever. Second can be true or false, whatever. I can straight away give the result as true only, right? Why to check the second one? Why to evaluate second expression by wasting time? No, I won't do that. That is not happening by the JVM here. So because the first is true, it is skipping the all remaining and assigning the true into the boolean. What is the value assigned to B? True assigned. Now second expression evaluated, not evaluated. Why? Short circuited. A plus plus not happened. So A value not increased. A is still 12 only. So A 12, B true. Is that clear? Got the point, guys? Who answered 13? Got the point? Okay. $122. In this, I'll do small change. At least this time, answer 100% right, guys. Please. 122, my lab. One small change only I'll do. 15 I am doing here. Remaining same. Yeah. This, think and answer it, please. Wonderful. Okay. So, evaluate. Do it. I am writing clearly, very clearly here. A plus plus less than 5. So A is the 12. 12 greater than 15 coming as a false. In the case of R, first is a false, we can't decide it. Now, second true means true. Second also false, the final result false. Because the first is false, I have to come to second only. Means first A plus plus. A plus plus, what is A value I have? A is already 12. So increase A value to 13. Okay, increased. Now 13 less than 5. 13 less than 5 is false only. False or false or false. False or false means R case any one true, true, otherwise false. Both false, false only. So the whole expression result is false. The false assigned to B. B is a false. 13 false. Everybody right. This time I got 100%. Everybody told right. So you understand, you are understanding the techniques to catch the points. See, some students will understand in one time. Some students will grasp, will get the technique in 2 times. Some students may get that in 3 times. So what is this number 1, 2, 3 I'm telling is the number of times you have to revise to master the concepts. So one time you study everything and you need again, you should be 100% clarity. You should have 100% clarity in every concept. If 100% clarity is not there, again you spend a time, study, practice everything. Second time. If required, do third time. Then only you will become expert in the knowledge, expert in the technology. Okay? So I want to see you as experts, not just I know Java, a little bit Erlang. No. You have to say that. You have to say in interview that. Ask anything in Java, core Java, or ask anything. You have to sit in interview and say that, ask anything, no problem. You can show that attitude only when you expert technology. Okay, answer all of you too. Let me to compile it. 122. Okay, guys, 39 false. That's about logical. So in this session, we have done relational and logical operators, guys. That's about this session. Remaining, we'll see the next session.